Yay! Yay! Here we are. Here I am again, and hopefully you are also jumping on board this train. Train stops at this station every time of day, same time of day, I should say, at 2 hours UTC. Howdy, howdy, howdy. Hope everybody's doing well this evening, at least where I am, it's this evening. I've got a kitty approaching. No, he decided to jump off. So no kitties on the lap yet today. Let me get all my doodads running here. And then I look at the chat over here. It should be showing live pretty soon. Yep, it is. Good. Another viewer. Hey. Just getting started here. Popping up all the various windows that I think we have to have. All right, there. It looks like I'm live. I'm going to check my audio. It's good to me. It's good to me. OMC Triple X in the house. Thank you much. Thank you much for stopping by, joining the circle. That's all this is. I guess I'm going to have to really look at this question here, OMCXXX. Whoa, man, that's beyond me. That is totally beyond me. Primarily because I don't have any interactions with chocolate ice cream these days. So yeah, I don't know. Maybe you can elaborate a little bit on that. Oh, all right. Oh man. Well, my density has brought me to you. So get used to that for sure. All right, I'm gonna have to think about that one a little bit because that's one of those things that I talk about where it's just like zoom way over. Anyway, hey everybody, this is Astronomy Daily Live. This is a daily live show where we have we bring in a circle of friends and we talk astronomy for an hour or so. And it happens every single day at 2 hours UTC. So you're going to have to figure out exactly what time that is, depending on where you are on this sphere, or theoretical sphere. But I think there's pretty good evidence that we are on the sphere. So I can say that pretty confidently that you're going to have to work out. You're going to have to do a little arithmetic, number crunching, to figure out exactly what time I'm going live where you are. Now, where I am, I'm in southeastern Arizona in the United States. And Arizona is one of the few states / locations in the United States that doesn't observe daylight savings time. So I am always on Mountain Standard Time. It's called Mountain Standard Time. And Mountain Standard Time is always 7 hours behind UTC. So if it's 2 hours UTC on January 22nd, then I have to subtract 7 from that. And if I do that, I get 7 p.m. local time. So here it's just after 7, and yay, we are here. We are here. I am here. The whole, well, we're bringing them in, slow but sure. I think I'm hoping that with some consistency and some marketing, this this show is going to go far, because it looks like it's going to fill a little niche or a vacuum. There are no daily live shows, sort of casual, about astronomy at all. There are weekly shows. There are a couple of I was actually aware of these and had forgotten about them, but actually I'm going to give my first shout outs of this show to some live streams that are happening over on twitch.tv. The one that I watched today is called CosmoQuest X, and it's hosted by Pamela Gay. She's an astronomer, lots of credentials. So I won't get into that much, but check her out on Twitch TV. CosmoQuest X is what it's called. There's also a group on Twitch. Let me get that here really quick. The drink of choice, actually, the drink of choice was coffee tonight, but I just realized that I forgot to do that. So no coffee tonight, which is fine, no worries at all. I guess I'm going to stick with the old standard, and that is hydrogen hydroxide. So tonight's chemical of choice to toast is hydrogen hydroxide tonight. So choose your poison carefully. Awesome. So let me I'm going to pull up that other twitch.tv channel. Oh, yeah, it's called Brain Bites TV. So Brain, B-R-A-I-N, and then Bites is like the computer bytes, B-Y-T-E-S TV. And there's actually a number of streamers in that group. Let me, since I'm here, I might as well run through it, because I want to give I think that giving out this kind of information, so you can watch all these other shows that are about, a topic that I'm interested in, and it sort of seems like, we are interested in. I like to sort of get as much of that as I possibly can. So, so Brain Bites TV. Let me see if I can get a list here. There's like 10 different streams. I'm still trying to figure out Twitch exactly. Just navigating around. I don't seem to have the kind of trouble that a lot of people have in terms of new things and figuring it out. You give me, a couple of minutes and I, basically work it out. So, when there's a big new version of Windows or a new version of Linux that looks and feels completely different. I seem to be able to adapt pretty well. So I'm going to look at the chat really quick just to make sure I'm not missing anything too important. Oh, where'd the chat go? Did I remove the chat? I might have. It's entirely possible that I could have done it. Yeah. Oh, you know what? Maybe I never popped it out. I never popped it out. Okay. And OMC XXX, I will definitely get to your questions. So yeah, I like to pop that out so I don't necessarily have to have YouTube running on the Linux machine, because for some reason, and maybe if you're a computer know-it-all, has experience or knowledge in these areas, I'm running Fedora 24 with Firefox, and the live YouTube streams always freeze the machine up. I mean, completely frozen. No mouse, no nothing, right? I mean, I've got to do, the hard reboot, and I hate doing that, right? Because it's not very nice. So anyway, Brain Bites. There is CosmoQuest Astronomy. There's Dream Machine, which is about car repair. There's Horizon Psi, which is astrophysics. There's Inertia TV, which is forensic anthropology. There's Jason M. Everett. He's doing flight dynamics. There's Kaboga doing exposing tech support scams. That's pretty interesting. Mike Sy does cooking. Nick's Saga does biology. Serpent AI does programming. Skylius does astronomy, and Starstrider does astronomy. So Starstrider, I know, is Pamela Gay, and I guess CosmoQuest X can sometimes be her, or it can be somebody else. So I'm gonna just a little bit. No, I'm gonna raise this a little bit. There we go. There we go. Now you can see my full, not just part of it. So that's what weekends are about. Just sort of flopping around. Actually, this stuff is about to go. So it's it's on its last leg. I cut it short, so I only have to do it a few times a year. I'm just lazy that way. So Astronomy Daily Live is a daily show. It's very casual, but also very sincere, and I can dive really deep, or we can keep it easy. This show is for newbies, it's for advanced amateurs, and it's for pros. So I would like this to be a big circle, and you're all welcome. We're talking about astronomy, not much of anything else. We'll talk about science, the scientific process. If there's like a rocket launch or something, or space news, please bring that up. I'm certainly not going to try to pay attention to everything. So, and yeah, it is exactly right now. And that's actually one of the things that I want to cover really, really quickly here. Last night, it just popped into my head that I wanted to sort of describe the difference between precision and accuracy. And I kind of fumbled that a little bit. A confusing topic, but I think I've got an analogy that works relatively well. So, and you're going to have to picture this in your mind, which isn't all that hard. Okay, so imagine, and at some point, I'm probably going to want to be able to draw these kinds of things, but I'm probably the worst freehand drawer ever, especially on a computer. I'm just not used to those kinds of things. I type a lot, but I don't really draw all that much. So I'm going to practice a little bit before I do that, because I don't want to make it any more confusing, right, than what this particular topic already is, and that is what is accuracy and what is precision. So let's take a dartboard again, okay, and let's say that I want to let me back up, okay, with two items, accuracy and precision. You can actually have four combinations, right? You can have high accuracy and high precision. You can have high accuracy and low precision. You can have low accuracy and high precision. And you can have low accuracy and low precision. And it's sort of like a grayscale. So you know, everywhere in between, but those are sort of like the edges, right? So if you think of a dartboard, okay, and if your goal is to hit the bullseye, okay, if you take one dart and you throw it, and it goes right in the center of the bullseye, it goes where you want it to go, okay, that is being very, very accurate, high accuracy. If you take a second dart and throw it, and it also hits the bullseye, then once again you're very accurate. Okay, now, stick with me. All right. Now, if you take that third dart, because you usually have 3 darts per turn, right? Take that third dart and you throw that and you hit the bullseye again. Once again, you are very, very accurate. Now, if you look at your 3 darts, okay, if they've all pretty much landed in the same place or are very, very close to one another, then they're also very precise. So your accuracy is high because you've hit your target, and your precision is high because you've been consistent. So all 3 darts have landed more or less in the same place. Okay, so now let's go on to like low accuracy and high precision. Okay, low accuracy and high precision would be if, you know, pull your darts off the dartboard, go back. How far back do you have to be for darts? Does anybody know? I think I have to pull up the rules. Don't remember exactly. I'm trying to a few times, and it was 20 some feet, or so. Yeah, does that sound about right? I don't know. Anyway, you back up to the line and you throw your darts again. Doink, then doink, then doink, right? Now, let's say in this example that what you end up with is low accuracy but high precision. What that means is that, if you're intending to hit the center of your dartboard, right in the middle, but say instead all three darts like land over here instead, okay, well, you're not very accurate because you're not hitting the bullseye, but all three darts are really, really close to one another, okay? So that's high precision. So that example would be low accuracy and high precision. So let's do another one, okay? The third one would be, let's just take high accuracy, low precision. Okay, what that would look like is if you took your three darts and you threw them, and you're intending, to hit the bullseye right in the middle, right? But instead, you hit over here and over here, say, and over here. And if you sort of take the average of where all those are, they're pretty nice and centered, right? They're not offset or anything. Those three darts are pretty nice and centered, but they're spread out a lot. So that means that your accuracy is high because it's overall they're centered, but your precision is very, very low. Okay. So the fourth one would be low accuracy and low precision. So it's almost exactly like the last one, except the positions of those three darts aren't centered. They're off. So they're off center and they're spread out. That's low accuracy and low precision. All right, so I hope that makes sense. As I said, I'm probably going to start wanting to draw some things from time to time, just because it's absolutely true. A picture is worth 1,000 words. I don't have to be blathering so much about all that. However, trying to get a picture that in your head is actually a very good exercise for doing science. A lot of the work that I do is happening in here, and the cool thing about that is that it's completely portable, right? So no matter where I am, it seems as though I've always got this stuff in here, right? So I use that tool, and I just use what could be called the imagination to try to visualize and to work all these things out. So instead of having information just sort of spoon fed to you, it's an exercise. It's an exercise in at least a part of the scientific process, and so trying to visualize what I'm describing is actually a nice exercise, and my job, therefore, is to try to find the correct language to explain it well enough to be able to help you put that kind of an image in your head. Cheers. Okay, so I just wanted to clarify that. And that is, this is one of the really, really cool things about a daily show is that I don't feel any kind of pressure or regret, right? And it's like, oh, you know, yesterday I really I didn't really explain accuracy and precision well, and and if this was a weekly show, um, I would probably just, you know, forget about it, right? And it would never come up again unless somebody asks. Because it's a daily show, I don't have to sweat it. It's like, I'll tell you tomorrow, or I'll tell you the next day. So that's extremely cool. I like it. I like it a lot. All right, OMC Triple X, your question is, how much impact do you think the sun's solar flares and uh, plasma ejections have on the Earth's seismic activities? I, uh, for my entire life, and this has just gotten more and more intense over the years. A big bright star in the sky is really running the show. Is running the show more than what we think. And there's ongoing work, mainly independent work. Solar astronomers and seismologists don't talk. I mean, they're in two different worlds, and there is uh, independent research at Ben Davidson with suspicious observers. He's much into that, and he's you know, he's not a trained scientist, so he doesn't have the, you know, years and years and years and years of experience doing scientific analysis and you know, the whole scientific process. But he's an extremely smart dude, right? Extremely smart guy, and he is figuring it out. And he it's kind of neat for me, you know, to sort of observe, you know, the process of him working all this out. And he's found some very interesting correlations. Now, correlation doesn't mean or doesn't imply causality. So, you know, there's still that. But he's found some pretty interesting correlations that are really, really strong. And if you jump on to the idea that the electrical nature of the universe is much more at work than what we think, then yeah, that there most definitely is some causality between activity on the sun and what is going on the Earth in many different areas: weather, climate. I mean, you know, we already know for a fact, right? You know, that the sun does affect on Earth. Now, how and why? Don't know yet. Don't know yet. So yeah, hopefully that answers that question for you. Everybody's doing good. Half an hour in. Hydrogen hydroxide tonight. So a couple more shout outs, and I want to try to do these pretty regular. Pull that thing. Weekly Space Hangout is really, really awesome. Those, I still have to remind myself when that's happening. Is that happening Wednesdays or Thursdays? I will find out. I will let you know. They are a Google community, so you can look up the Weekly Space Hangout crew, the WSH crew, on Google communities, and you can find that group and their weekly podcast there. So that's a great show. Got some smart people on there talking astronomy and space, and giving us the lowdown on work that is being done in this area, and they're very, very awesome. Big shout out to Dennis Hands. He does a live show a couple of times a week on Snapchat, and he's an educator. He's been an educator for like 40 some years or so he really knows his stuff too. Love his sense of humor. I think he's great. I think he's very awesome. I'm going to go back to that, or I'm going to pull up the chat here too, so I don't miss a thing. Don't want to miss a thing. So yeah, go over to Snapchat and look for Dennis R. Hands. And as I said, he does a couple of shows a week, I think on Monday and Wednesday. Don't remember exactly what time. I'll try to accumulate that information as we go along here. Deep Astronomy is another great podcast. Tony Darnell hosts that, and he has a YouTube channel, T Darnell, or just do a search for Deep Astronomy. And he usually has a panel and a couple of guests, and the guests talk about the research that they're doing. They usually have just come out with a paper, and that's sort of how Tony seems to find them. And he invites them on to talk about the paper and all that. The interesting thing about that, and sort of some inside information about that, is usually it's sort of a process to publish a paper, and usually if it's a peer-reviewed one, it's going to take a few months or so, right? Because you first you have to write it, right? And that may take years. But then, once that's written, you send it off to a journal and/or journals. And people may not know this either, but astronomers have to pay to publish. So it's very, very expensive. I'm trying to remember. I haven't published in quite a while or been involved that much. I've been co-author on most of the papers that I'm on, and so I don't really get into the budgets or anything like that. But the couple of papers that I was primary author on, I want to say, at least at the time, and this was quite a while ago, it's like $300 a page. That I don't know what it is now, but yeah, the astronomers have to pay to publish. It isn't a free thing. So you submit your paper, and most journals are peer reviewed. So what that means is that paper is sent out to 2 or 3 or 4, maybe more, anonymous peers, also astronomers, um, who have some expertise in the area that that the paper is talking about, and they'll go through the paper and make comments and suggestions, and ultimately, sort of give it a yay or a nay. If it's a nay, then they usually, make these comments and suggestions as to what the authors need to do to sort of make it pass by them. If they get a yay, then it's like, well, yay. Cheers. So once that's done, once all the peers have given their okay, then the publisher has to get it, and they have to make it up as if it's going to appear in the journal. I think that's called a proof. They send that proof back to the author. The author looks at it, makes sure there aren't any typos, make sure that all the pictures and all the plots and all the tables and everything are correct and maybe placed correctly. Make sure that all the references are right. Just go over it to make sure that it is exactly what they want it to be. They send it back to the publisher, and the publisher puts it in the queue to be published. So that whole process, may take 2 or 3 or 4 months, or maybe even more. So when Tony on Deep Astronomy finds a paper, either on like archive.org or actually, in or at one of the journals, that paper is already a few months old. And so, he's talking to the authors of this paper. And, these poor guys are going to have, they have to try to remember what the paper was even about, sometimes. So, yeah, but that's a great show. Great show. And as I said, I was aware of the Twitch TV streams. Had never watched any of them yet, and I watched my first one today. It was in CosmoQuest X with Pamela Gay. She was talking about how she reduced or analyzed some of her data for her master's thesis. So she was just sort of explaining that process. So that was very, very cool. Definitely want to watch that more. Pretty interesting stuff. For sure. So I hope that this is sort of a good time for everybody who is viewing, either in, right now. I guess if it's in the future, it's sort of arbitrary, right? It doesn't really matter. But is this sort of a good time to be doing this live at 2 hours UTC? Let me know. It's there's absolutely no way that I'm going to be able to satisfy everyone, but So, but I've got a lot of flexibility in terms of schedule and all that. So maybe if this gets popular enough, I can have a couple of shows a day, or have one set show, and then have just sort of a random during the day stream for half an hour or so, because 2 hours UTC is pretty nice for North America, South America. It's pretty good for Asia and Australia, but it sucks for Europe and Africa, because in Europe and Africa it's the middle of the night. So unless you're a night owl and don't have anything else to do in the middle of the night, that's sort of an inconvenient time. But can't please everybody, so for the moment it's going to stick with this 2 hours UTC. I've got a kitty here that's playing with a pen. Let's see if I can get him to reach all the way up here so you can see his paw. Oh, there's his head now. Some of the kitties just love chewing on pens, and that's exactly what he's doing now. So I was very, very rude to bother him like this, but sometimes you just have to, All right, I'm not gonna mess with that anymore, so you'll settle back down. But yes, happiness is a purring kitty in the lab. For sure. For sure. All right, you got anything else? OMC Triple X, are you still in there? Let me I'm gonna spy on you here and see. No, it's just me. It's just me. Okay. Cool. Well, it shows that I've got another viewer at least. So hey, I'm gonna keep going here. I've got that's one of the really, really cool things about astronomy is that there's always something to talk about, always something to figure out, always something to think about, because astronomy is the study of everything, and that's why I'm just crazy about it, because when I was a kid, it's like I was interested in everything. So it's like, how can I study everything? Well, become an astronomer. Most people think the astronomers they study stars and galaxies and all that, but it's so much more than that. It spans from the subatomic to the cosmological. So from the smallest to the largest, and from the slowest to the fastest. It does the whole thing, and if you're into the Big Bang, okay, it studies all time as well. So it's like, so what could be better than that? So there's always something to talk about. So I'm going to look at my list here and see if anything catches my eye. Maybe now is a time. Yeah, maybe now is a good time to at least start my rant about citizen science. Now, citizen science, if you don't know what that is it's a means for sort of regular old people, not old people, but just regular people of any age, to participate in scientific research. At least that's how it's sold. And as you can probably tell, I've got a little problem with citizen science. Um, uh, and I think the the motivation forces well the motivations for citizen science are very, very valid and very, very awesome, and I think it should continue. But um, uh, well, here's sort of how I see it, and maybe this is opinion, but this is sort of how I see it, at least. Um, uh, Scientific research, especially institutional scientific research, is usually very, very underfunded. Um, Nobody ever has enough money to do exactly what they want, and since everything is run with money, um, the more you have, the more you can do. The less you have, the less you can do, and everybody's got their hand out, right? Everybody wants a piece of the pie, and the pie is only so big. And so, uh, through various agencies, like the National Science Foundation, most um, departments, executive level departments, like Department of Energy and Department of Defense and NASA and all those also have means of funding scientific research. There are also independent institutions. There are Kickstarters. There are Patreons. There's lots and lots of ways to get funding, but it never seems to be enough. So researchers never have enough money to mainly pay the people that they need to get in order to get the work done. So that's a legitimate problem, right? And how these things go. If there was a political will to do it, it would be done. But there isn't a political will for various reasons, which isn't really related, to this show. But funding is always really, really low, and there doesn't seem to be the desire or the will to um, increase those funds. So researchers are sort of stuck, and we're moving into an era in astronomy, and I think in other sciences as well, where there's just like a ton of data. There's, terabytes and terabytes and terabytes of data. And as good as software developers are, I being a software developer as well, as good as we are to write the code, to process all of this data, that code just isn't good enough yet. And what it's going to take in terms of that to make it good enough is still a question. Machine learning, AI, don't know. Don't have an answer for that one yet. But for a lot of problems that need to be solved, one of the first things that you have to do is you got to sift through all this data, just tons and tons and tons, and it's only going to get more as time goes by. Just there are terabytes and terabytes and terabytes daily, right? And something or someone has to go through it all, and researchers don't have the money to pay the programmers, the army of programmers needed to write the code to go through all of this data and do a very, very accurate and precise processing, because that's, of course, what a scientist wants. They want to be very, very accurate, and highly precise. So they want to get the right answer, whatever it is, and they want, every time they get an answer, they want it to be consistent, so it's precise. And it turns out that a lot of things, human brains are just still better at it. But then there's a dilemma then, right? Because if it's all it takes is a human brain, well, it's like, well, how do we get a whole bunch of people to run through all of our data without having to pay them? Because we don't have a budget for that. If we had a budget for that, we would we'd pay a pro. And so this is a problem that has been written about by none other than Mark Twain. Okay, and I actually looked this up yesterday. In the happen to have the Mark Twain book here, and it's The Adventures of Tom Sawyer. Okay, and the second chapter is called The Glorious Whitewasher. And Tom has a similar problem. It's not exactly the same, because his motivations are slightly different, right? But he's got the same problem. He's got this thing to do, and he can't. He doesn't have anything that anybody would want in sort of trade for this work. See, Tom has to whitewash the fence, right? And it's got to be just right, because it's right out in front of the house. It's got to look perfect, right? But he would much rather go fishing or anything, right? Anything but do this. So as I said, it's not exactly the same kind of problem, because astronomers they would prefer to do this, right? But they just don't have the budget to hire people to do it. So, but what Tom does is extremely similar to what these astronomers do, and that is that he actually Tom he sells this work. He's like, look, this is really, really cool stuff. Okay, what I'm doing is really, really awesome, and it's also it takes a fine, sharp mind to do a good job at this whitewashing of this fence. And so I can't trust this to anybody. It's got to be done. It's got to be done right. Yeah. And he actually gets to a point where he has convinced his friends to do his work for him. And not only that, they're paying him to do it. So they are giving him stuff, rocks and pieces of metal. I forget exactly. There's a big long list, right, of stuff that Tom is able to accumulate while he sits back and watches everybody else do his work. Now, as I said, that is definitely not what the astronomers are looking for, right? Is for somebody else to do their work. Astronomers want to get in there, man. They want their hands dirty. They want to get into the data. They want to do the analysis. They want to write the papers, all of it, right? But they've got this problem that's sort of similar to Tom Sawyer's problem. And so what astronomers have done is they've figured out a way to market this thing in order to solve this problem. And so what they do is they convince a whole bunch of people, citizens, perhaps even non-scientists. They set up a situation where these citizens can run through all of this data and sort of do the kinds of things that the computer software can't do very well yet, and may actually never do well. So as you can see, it's sort of the same kind of a thing. The astronomers are getting free labor, and the citizens are they're actually getting something too, but that's just like Tom Sawyer's friends. They are getting the satisfaction of knowing that they helped whitewash this fence and did a darn good job at it too. Did it very precisely, and it looks beautiful and everything else. But that's I think that's a little delusional. Even if Tom was like, look, when you're done, okay, down here in the corner, okay, I'm going to carve your name into the fence wood, okay, with the date. So everybody who walks by will know that you participated in the whitewashing of this fence. Okay, well, that's exactly how, at least one of the reasons why the citizens do this, because they know that they are going to get some kind of recognition, either their name in a paper that results from this work, or they'll be mentioned on a live stream or a podcast, or in any kind of a presentation. It's like, thank you, citizen scientists, for doing this work that we can't do. So I mean, it's a legitimate problem. It's just I don't necessarily like how it's sold. But I guess if everybody is happy with that, and everybody at least thinks they're getting something out of it, very, very cool. No problem. It's just my opinion. The other thing that I don't like is the actual term citizen scientist. I've looked at several of the citizen science projects, and there are many of them. In fact, let me I've got to share my screen at least once during this live stream. And wow, we're coming up on an hour already. I'm just gonna, and you can do this too, of course, but since I'm here, I will just citizen science projects. I found this on Wikipedia. It's just a list of the citizen science projects, at least according to Wikipedia. All right, so I'm going to share the screen, and I'm going to sing my little song, and then we're going to go warp. I really think that's awesome. Here's the list of citizen science projects. And whoop, I don't know how I did that. Back. And as you can see, there are many. This is in alphabetical order. So here's all the A's. Look at this. And every science, all the GY sciences, lots of entomologies and environmental science, seismology, meteorology, hydrology. Of course, there's astronomy. There's lots of astronomy. And all of, well, I can't say all of them because I haven't looked at all of them, but at least the ones that I've looked at, it's some kind of, it's usually like an identification thing, like the moon mappers, right? There's a moon mappers here. We can go to that. Moon mappers. Let's go to moon mappers. And what this is just grabbing of the moon with like the Lunar Reconnaissance Orbiter. Let's see, map the moon. And identifying craters. Oh, you have to log in. All right, well, I'm not going to be able to do that. But yeah, just it's identifying and circling craters. I think they're doing other things too. You have to look at the details a little bit, but the basic idea is that they are identifying craters and maybe other features on the moon, which the computer software really has a lot of trouble being able to identify craters as well as the human brain. So, but that's, at least my understanding is that that's pretty much all that these citizens do. So, call them a citizen scientist. That's for me, that's a really, really big stretch. I'm going to stop sharing. I'm going to not slouch. There we go. There we go. To call them scientists when they're not really doing science, they are participating in one part of science, and that is basically collecting data. So they're taking, like in the case of moon mappers, they are looking at these images and identifying where the craters are and the sizes, and that is sort of the raw data that can then be later analyzed by software that is able to do that kind of a thing. So yeah, I've got sort of two problems with citizen science. The first is just how it's sold to the citizens. It's very much like Tom Sawyer and the White Fence, and I don't. It's not exactly the same, but it's sold and marketed as something that it isn't. And then the other thing, as I just said, is that being a citizen scientist. No, these volunteers are not participating. They're not doing the scientific process. They are helping in the creation of the data, which is of course an essential part of the scientific process. But the scientists are doing the science, not the non-scientists. So that's, maybe that's just a terminology thing. As I said, this is just my opinion. I'm a skeptical hard-ass dude, and but I'm very open-minded as well. So I would certainly be, open to a debate about this, because I do see that there's a lot of value in this work, and I think both sides are benefiting. So I don't necessarily see this as a bad thing. I don't necessarily like how it's being sold. There's not. Yeah, it's just it's really close to being the Tom Sawyer situation, and that's just I mean, that is being fooled, right, into thinking that you're doing something extraordinary that nobody else wants to do. So as I said, it's not exactly the same thing, but it's got that smell to it. How about that? It just sort of smells like that. All right, well, cool. I think trying to think if there's anything else that I want to cover tonight, because as I said, this is, one of the cool things about having a live show is that I don't feel any kind of pressure to try to cover a bunch of topics, or even cover one topic completely, because there's always tomorrow. Usually there's always tomorrow. So far there has been. So we're doing good. We're doing good. This the whole idea of citizen science does sort of shine a bright light on what I don't really have a term for it yet, but it's sort of like science from the desk. There is so much data, astronomical data and other data, but let's just focus on astronomical data. There's a lot of astronomical data, old and new, that is available online for anybody. A couple of shows back, I showed the data coming down from Iris. I'm going to show that screen too. Let me share it first. Come on, turkey. There goes infinity. All right, so we're going to come back over here, and I'm going to do iris. This. That's it. So the interface region imaging spectrograph. Okay, and this is data that you have available to you, literally like hours after it's run through this spacecraft orbiting the Earth in a polar orbit. Right? Look at the timestamp on this. Okay, that's the 21st of January, which is today, at 12 hours 40 minutes UTC. So here, locally, where I am, that would have been at 5:40 this morning. So yeah, 12 hours behind. Let's refresh. Make sure that we're completely up to date here on that. Yeah, so I mean, you know, at the moment we're a little behind, but wow, you know, isn't that amazing that we can get like this either processed data or raw data from a spacecraft orbiting the Earth in a polar orbit, looking at the sun in the ultraviolet, and we have the data right here. And if I was studying some aspect of the sun that required this data, it's all I have to do is come down here. I'm going to sort of scroll through this because it's fun to watch the movies if you can find an interesting one. Usually the you know, like the prominences on the edge, kind of neat to see. But let's just look at a bubbling one here. Let's look at this one. All about. So, you know, looking at multiple wavelengths. Okay. Actually, these are the wavelengths in angstroms. Yeah. So 1,330 angstroms would be the wavelength. 1,400 angstroms, 2,796 angstroms. Blah 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 blah. So those are the images, and here's some spectra. And here's some other stuff. Da 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 da. Let's see. I don't think. Yeah, this. These movies aren't available yet because it's still pretty new. So let me go to. Let me go down, and I hope this is a little helpful and useful for you to sort of see how, at least grab data from these things. So let's sort of see if, yeah, okay, so here's some. As you can see, I've just sort of randomly grabbed some stuff here, and I think this JavaScript movie, let's see if it wants to load. Oh, yeah, it is. Let's see if we have a scanning thing, or if it's just a nice movie. So that'll load for a little while. I'm not going to translate this page. Yeah, so it's scanning a little bit. This is still loading. Once it's completely loaded, it'll go into movie mode, and you'll see a little bit more action on that. But this is just a region of the sun. This spacecraft IRIS, 8-inch telescope. So it's exactly, in terms of, you know, the telescope itself, it's exactly the same size as my telescope. So, you know, just based on that, I can gain an understanding of what this spacecraft is capable of. And yeah, they're doing some awesome stuff. You might see this black line right down the middle here. That is a slit in the CCD array that allows light to go through it and go onto a spectrometer. And a spectrometer just spreads the light out, so you can do other kinds of analysis. And at some point, I'll definitely, especially if asked, I'll get into spectroscopy and what that is all about too, because spectroscopy is really where you start looking really, really hard at your data. Images can't, I mean, it sort of depends, but images can't provide you with the kind of information that like a spectrometer can. It's different, I guess. Anyway, I think, yeah, this thing is still loading. It was like 280 images or so. So as this thing sort of goes. Anyway, as you can see, this thing is sort of moving back and forth. So this spacecraft has the ability to scan. So it's actually moving. I think I have to look at the description of the spacecraft itself, but I think it's moving some mirrors out of the telescope in order to scan. Maybe it's moving the CCD array. I don't remember exactly, but it is scanning around just to provide even more information for the spectrometer. And they're looking at a just a region of the sun that they have an interest in. I'm not exactly sure how locations on the sun are selected. Whether it's similar to getting like telescope time on Earth, where you write a proposal and you say, okay, I want to look at this particular region on the sun. I would think that they would have to be a little more opportunistic and maybe have a queue where it's like, different scientists say, okay, I want to look at this kind of a phenomenon. And when that kind of a phenomenon occurs, the IRIS folks on the ground can instruct the telescope to look there and collect a certain kind of data that is specified by the researcher and all that. So this is slowly loading still, but I'm going to patiently wait as you are to have this completely loaded, because then you'll be able to sort of see it. There's if I scroll down here, you can actually see what time it is too. So this is happening, relatively fast. This is 3 hours, 26 minutes, 50 some seconds, and it's every image looks like it's going by like every 15 seconds or so, something like that. So this is pretty rapid data acquisition here. I'll also see what day it was. January 11th, 3:31 Universal Time. Astronomers talk in Universal Time. There's there, as OMCXXX said. I don't know if he's still around or not. I don't think he is. But there's only one time, and that's right now. And that's absolutely true. Absolutely true. Now, did this thing... oh, it's only got 2 more images to go, and it's done. See, it's saying loading 256 of 258. So I don't know why it's not loading those last ones. After all that, I'm not going to be able to. I'm not going to be able to load it, am I? Damn it all! Hate it when that happens. Anyway, check this out for sure. Good stuff in there. Hope it's not too boring. It's the sun, so I mean, it can't be incredibly boring. Always fascinating things going on with the sun. But yeah, it's having trouble loading these last few. I wonder if I can just reload it and it'll just zip right through. It did. Yeah, it's having problems with those last. Oh, there it goes. There's one. There we go. There we go. Oh, I'm going to say nope here so we can see the whole thing. And you can see the time down here, the timestamp, right? You can see the sun just bubbling away. It's sort of harder to see on the live stream. But as you can see, it's scanning left and right. That slit is moving left and right, so they're collecting a lot more data than if the slit was just stationary. And they're looking at sort of an active region there. You can sort of see where it's brighter and darker, and just bubbling along. You can see these streaks here. I don't know what's going on there. Who knows? Cool stuff. Cool stuff. So anybody has access to this, and this is just some of the data that's available. There's tons. Boom Shiva. So lots and lots of data that's available, and that's sort of what I do. Okay, I've got access to all of this data that I would never ever have access to otherwise. Do you know how much it costs to put a satellite into orbit and then operate it? Holy moly! Okay, so this is very, very cool. We have access to tons and tons and tons of data. Anything that I want to do, I can going through the scientific process. One of it is collect data, right? And this there it is. So it's very, very awesome. All right, I think I'm gonna exit for now. It's been great as usual. This is a big rush for me. Definitely, if you haven't subscribed to this channel yet, definitely subscribe. Hit the like button down there. I don't know if it's over here or over here yet. I'm still trying to figure that out. And share this video with others that you think may be interested in this kind of stuff. I'm going to be here every day. I have no plans to change that, because there's always as I said, there's always things to talk about in terms of astronomy. So because we're talking about everything, and everything's a lot of stuff. So yeah, tons and tons to talk about. And as I said, this consider this like a circle of friends that are getting together every day, sitting down and just having a chat. So this isn't necessarily me just answering questions, although I'm happy to do that. But I reserve the right, to answer or to ask questions too. But especially when we start getting some pros in here, and some people who at least think they know what they're doing. I think I know what I'm doing, but that's just a matter of opinion. So, but it's supposed to be really, really fun. But I also want it to be, really, really hard. We're not going to accept any fluff. So at least am going to be skeptical, but very open-minded. But I want to learn and I want to know. And there's always more. Bucky Fuller said, "You can never learn less. You can only learn more." And that's different from forgetting, right? But just in terms of learning, um, there as far as I know, there is no process to unlearn things. You can't learn any less. You can only learn more. So we're sort of stuck with that. So I'm going to go with it. And all right, well, as I said, I'm hoping that this channel grows, this show grows, get a larger audience as time goes by. I do have a lot of interest when I make a post saying that I'm going to be on. I get a lot of likes and I get a lot of interest and I get a couple more subscribers. So very, very cool. If you're watching this in the future because you missed it, you have to figure out what time it is for you locally. I can't tell you that because I don't know where you are. I can give my example, uh, and that's about all I can do there. So 2 hours UTC every single day. And speaking of every single day, I will see you again in 22 and a half hours. All right. Live long and prosper. I'll see you later. Peace out.